Determine the following information for the parabola given by f of x equals 2 times the square of x minus 2 minus 4, then graph the parabola. The quadratic function is in standard form or vertex form, which is the form y equals a times the square of x minus h plus k, where h comma k is the vertex and the axis of symmetry is x equals h. In addition, if a is positive, the parabola opens up. If a is negative, the parabola opens down. Let's begin by identifying the values of h and k. Notice h is equal to positive 2 and k is equal to negative 4. This indicates the vertex is the point 2 comma negative 4 and the axis of symmetry is x equals 2. Let's plot the vertex 2 comma negative 4. Let's also sketch the axis of symmetry, which again is a vertical line passing through the vertex. Next, we want to determine the exact x-intercepts. The x-intercepts are where the parabola intersects the x-axis. Every point on the x-axis has a y value or function value of 0, which indicates to determine the x-intercepts, we set f of x equal to 0 and solve for x, which gives us the equation 0 equals 2 times the square of x minus 2 minus 4. And now we need to solve for x. We first add 4 to both sides. Next we divide both sides by 2. Simplifying, we have 2 equals the square of x minus 2. And now to undo the squaring, we square root both sides of the equation. But remember, when we square a positive or square a negative, the result is positive, so we will have two solutions. To get two solutions, we need to include a plus or minus on the left. So again, square rooting both sides and including a plus or minus on the left, we now simplify. The square root of 2 doesn't simplify. We have plus or minus the square root of 2 equals on the right. The square root of the square of x minus 2 simplifies to x minus 2. And now we add 2 to both sides, which gives us x equals 2 plus or minus square root 2. This indicates the two x-intercepts are the points 2 minus square root 2 comma 0 and 2 plus square root 2 comma 0. To plot these on the coordinate plane, we'll want to get decimal approximations, which I've already done. The x-intercepts are approximately 0.59 and 3.41, which we'll say are, let's say, approximately here and approximately here. Again, this x-intercept on the left would be 2 minus square root 2 comma 0, and this x-intercept would be 2 plus square root 2 comma 0. Notice they are symmetrical across the axis of symmetry. And now let's determine the y-intercept. The y-intercept is where the parabola intersects the y-axis. Every point on the y-axis has an x value of 0, which indicates to determine the y-intercept, we set x equal to 0 and solve for y, or determine f of 0. F of 0 is equal to 2 times the square of 0 minus 2 minus 4. Simplifying, we have 2 times the square of negative 2 minus 4. The square of negative 2 is positive 4, giving us 2 times 4 minus 4, which is 8 minus 4, which equals 4. The y-intercept is the ordered pair or point 0, comma 4. Let's go ahead and plot this on the coordinate plane. Notice the y-intercept is 2 units to the left of the axis of symmetry, which means there must also be a point 2 units to the right, which would be here, the ordered pair 4, comma 4. Now that we have enough points, let's go ahead and graph the parabola, and now determine the domain and range. Recall the domain is a set of all possible inputs or x values. There are no restrictions on the domain, meaning the domain is all real numbers, which using interval notation is the open interval from negative infinity to positive infinity. The range is a set of all possible outputs or y values. Because the parabola opens up, the range is y greater than or equal to -4, or the interval from -4 to infinity closed on -4. So we have the interval from -4 to infinity. Because the range includes -4, we have a square bracket to the left, and we have a parenthesis to the right of infinity. I hope you found this helpful.